Back with more equations, inequalities, and nature of roots. And we're solving for x and y in this slightly trickier simultaneous equation. When people see fractions, they start to freeze. And so we definitely need to look at this one and sort it out. So I'm going to go for a common denominator over here. So I'm going to say this is y plus x over xy. I'm going to leave this as 3 over 1 because I can then multiply through by xy. So I can now say y plus x is equal to 3xy. So that's one of my two equations. My second equation, I can work with a little bit as well. Let's say that x is equal to y plus a half, which means that x is equal to 2y plus 1 over 2. All right, so I can make that equation 2, and now I'm going to put those together. So I'm going to sub 2 into 1. And now I've got y plus 2y plus 1 over 2 is equal to 3 2y plus 1 over 2 times y. Okay. I don't like those 2's in the denominator, so I'm going to multiply everything by 2. So that's going to give me 2y plus 2y plus 1. This whole thing is over 2, so it's going to be 3y times 2y plus 1. Right, so I've got rid of all those denominators that I didn't want. So now I've got 4y plus 1 equals 6y squared plus 3y. So let's just see what I can get out of here. That's going to give me minus y minus 1. Okay. That should factorize for us as 3y and 2y. I want a negative 1 in the middle. So it's going to be minus the 3 and plus the 2. So y is equal to minus a third, or y is a half. And then I have to go back and work out what x is. So I'm going to sub back in. X is equal to y plus a half, or x is equal to y plus a half. Little bit messy over here, but nothing that we can't handle. That's eventually going to give us 1 over 6, or x is 1. And I have solved for x and y. Right, so slightly trickier simultaneous equation over there. All right, let's have a look then at question 6. Or rather question 5.2, I've numbered it because it's the second simultaneous equation. And there it comes. Okay, so now I have the exponential equation to deal with. So I'm definitely going to deal with that first before I even look at the other equation. So exponential equation, I think you know by now that you're aiming to get the same bases. 2 is the base, so y minus 3x is equal to minus 4. And let's just rearrange that a little bit. And that's a lovely equation 1. Okay, so we got ourselves out of a bit of a pickle there. Now I'm going to sub into equation 2. So that's 1, that's 2. So I've got x squared plus x times y is equal to 24. So the whole question actually becomes rather nice now. So x squared plus 3x squared minus 4x minus 24 is equal to 0. I've brought the 24 across because I know that it's a quadratic equation. 4x squared minus 4x minus 24 is equal to 0. So I can divide everything by 4. And there's that old favorite with 6 again. So you're going to get very used to seeing 6. Always be careful as to whether you're choosing factors of 3 and 2 or 6 and 1. So x is equal to 3 or x is equal to negative 2. Sub back into 1. Y is 3 times x minus 4, or y is 3 times x minus 4. And we have y is 5, or minus 6 minus 4 is minus 10. So we have solved beautifully for x and y. All right, so two simultaneous equations that aren't quite just the boring normal. Okay, a couple of quadratic inequalities then. The first one for 4 marks is one of those that you've got to have your wits about you. It's a little bit on the edge of the curriculum, but nothing that you can't manage. So my numerator is negative. My answer is also negative. So now you're saying a negative divided by what gives me a negative. And our conclusion is that the denominator has to be positive. That's the only way you can get a negative answer. So if my denominator has to be positive and my denominator looks a lot like a smiley parabola, where my x-intercepts are 1 and 5, I'm choosing greater than 0, so I'm choosing where the parabola is positive, which means I am choosing to the left of 1 and to the right of 5. So x is smaller than 1 or x is greater than 5. Okay, so not a completely unusual question. You've just got to have your wits about you. Next up, similarly, to have your wits about you this time, this bracket is squared. If it's squared, it's automatically positive. Okay, it could be 0 or it could be positive. The solution has to be negative. So now you're saying a what times a positive makes a negative, and therefore 2 minus x has to be negative. I'm going to put in the possibility that 1 minus x could equal 0. And I'm only putting that in because they said less than or equal to 0. So it's there as a backup in case I need it. Right, so this one, I'm going to do it in a traditional fashion, just so that I can remind you that in an inequality, if you divide both sides by a negative, you have to change the inequality sign around. So x is now greater than or equal to 2, which means that we do need this, because this one says x could be 1. So I have to have both parts of that solution. So x is greater than or equal to 2, or x is equal to 1. That's why it's worth 3 marks. Right, the last one that I've chosen to put in is a more traditional one, but it's already been factorized. So I've deliberately not given the normal factorize solve inequality. The thing to watch out for with this one is if you multiply out, which we're not going to do, but if you were to multiply out, this would be a negative x squared. And if it's a negative x squared, then we know we're dealing with a negative parabola. And so I've got to watch out for that if I'm looking for my solutions. If I'm going to draw a parabola, either I'm going to have to draw a frowny parabola, or I'm going to switch this bracket around. So I'm going to do that. So I'm going to change this to x minus 2. But in doing that, remember, technically I've taken out a negative 1. And that negative 1 that I've taken out, I'm going to divide on this side. So 0 divided by negative 1. But now I'm dividing by a negative. So I have to switch my inequality sign around. Okay, so if you do a switch around, remember you also switch the inequality sign. Now I've turned it into a normal little happy parabola where my critical values are 2 or 1. And again, I'm choosing the greater than or equal to 0. So I'm choosing those two pieces. If it was less than or equal to 0, I would choose x is between 1 and 2. But I'm not choosing that. I'm choosing the outsides. So x is less than or equal to 1, or x is greater than or equal to 2. All right, so just watch for those annoying little catches in your quadratic inequalities. Right, let's have a look then at nature of root style questions. First up is a fairly obvious nature of roots in that they've given you f of x. They've said it's got 2 equal roots and p is negative. And we must determine the coordinates of the turning point of a different graph of h of x is equal to f of x minus 3. So there's a lot going on here, because obviously I'm first going to have to work out what p is before I can even get to see what f of x looks like. Okay, so 2 equal roots. For equal roots, delta equals 0. So now I know that I'm doing delta. And remember, for delta, anything in front of the x squared is your a. Anything that is the coefficient of x is your b. And anything that doesn't relate to x at all is c. So my delta is going to be b squared minus 4ac. And delta is 0. So the 4's cancel, and I'm left with 0 is equal to p squared plus 4p. So I can take out a common factor of p. So p is 0 or p is -4. And because they told me that p was strictly less than 0, this one is not applicable. And so now I can say f of x is x squared minus 4x plus 2x plus 1, which we can simplify to look like that. All right. So now, if I want the turning point of this parabola as it stands, then I'm going to have to look for my P and my Q, my axis of symmetry and my minimum or maximum. So this is a particularly lovely question because it is already a perfect square. And so the turning point of f of x is 1, 0, which makes sense. If it's got equal roots, means it's got two equal solutions. It's turning on the x-axis. So now to get the turning point of h of x is f of x minus 3. And so the turning point for h of x has to be 1 and -3. Okay, so if we start with what's familiar, eventually the question just makes sense as we progress. Right, we have just 2 to go. Question 8, what values should k represent so that the nature of the roots of these two equations will be the same? Okay, so clearly we can get the nature of the roots of this one. And then we can use that answer to work out k. That's why it's only worth 4 marks, because it actually starts with a proper little level 1, b squared minus 4ac. So 1 minus 12 is -11, which means no real roots, since delta is less than 0. So that means that for the second equation, delta is also going to be less than 0. So for the second equation, new delta, b squared minus 4ac will be k squared minus 16k, and that has to be less than 0 because they have the same nature of roots. So k minus 16 less than 0. And the good news is this is just a normal quadratic inequality. 0 and 16. So that's my critical values. 0 and 16. I want less than 0. So I'm taking this bottom part of the parabola this time. And so I'm going to say k is any value between 0 and 16. Okay, the last question is a little bit more subtle. So they've given us f of x, which is a parabola. They've given us g of x, which is a straight line. And then they've given us p of x, which they say is the parabola plus k. And the question is, what are the values of k for which P and G will never intersect? Okay, when will the parabola and the straight line never intersect? So, if I assume intersection, then I'm allowed to make P of x equal to G of x. So P of x is minus 2x squared plus 4x plus 16 plus k. G of x is given. And so if these two graphs intersect, then I would be able to get solutions for that equation. Okay? If they intersect twice, I will get two solutions. If they intersect once, I will get one solution. And if they don't intersect at all, then I will get no solutions. And so the not intersect means no solutions, and no solutions is no real roots. No real roots. So all I want to do is say, for what values of k will this have non-real roots? So for no points of intersection, delta has to be less than 0. So if I go into delta again, that's my A, that's my B, and that's my C. So delta equals B squared minus 4AC. Careful here, it's minus 4 times minus 2 and then times 12. So 12 eighths are 96, and k times 8 will be 8k, and it's less than 0. So I have 8k plus 100 is less than 0, which is a linear inequality. So I'm dividing 100 by 8. And that simplifies down quite nicely to minus 25 over 2. So k has to be any number smaller than negative 25 over 2. And if it is, then my parabola and my straight line will never intersect. So please remember that this will not intersect, will intersect once, will intersect twice. Please remember that that is the same as nature of roots, delta greater than 0, delta equal to 0, or delta less than 0. Right, I hope that gives you a bit of an insight into some of the different questions that they could ask you on equations, inequalities, and nature of roots in places where you might otherwise have been taken by surprise.